Well, greetings and welcome to Nani Notes. This video, the instruction video to go with a class activity, a compass construction activity for reflections. And it's in our McGraw Hill textbook over here, pages 77 through 81. This is lesson 11 or 111. So, it's a little bit different. And we've done a lot of these before, but this is slightly different than the way we did it in McDougall-Attell. So stay with me here. There's going to be three stages. We're going to, we'll look at a reflection. We're going to verify. Then we'll go through how to construct a singular point, and then we'll construct a quadrilateral using a wee shortcut that we've had before. Ready? All right. Part one, let's verify. Now, I'm given here that I've got the pre-image STV and the image S prime, T prime, V prime reflecting over K, the line K. So, you know what? The way we're going to do this, I want you to take your compass. I want to see the marks. So go ahead and take your compass and give it a spin. Now, I'm going to show you full circles here, and we know we can use arcs, but this textbook, McGraw Hill, they like full circles a lot. So unless we're going off the page, let's go with full circles. So reverse your compass, and we're going to give it a spin the other way. Oh, that's so much fun. And the point here is that you're going to see, look at that, right there, right there. That is a very, very, very familiar construction to us. It's the one we've been doing right from the get-go. That is the perpendicular bisector construction. I want you to do it for each of these sets of points so that you can really own this. I want you to really know that this is true from T to T prime. Animate it. If you had colored pencils, you could maybe make your circles different color like you do in GeoGebra. That would be kind of cool. Flip your compass around and give it a spin the other way from T prime back to T. And again, check out those two circles. They again demonstrate that K, the line K, is indeed the perpendicular bisector of T prime. I like that. So again, this activity, this part one, all you're doing is verifying. You got to open the gap up a little bit wider, and I want to see this one. Woo! Does that fit on the page? Look at that. I went off the page, off my imaginary page. So there you go. That's one. Flip it around. Let's go the other way. And in each case, we clearly have demonstrated through our intersections that we've done or that these 2 points, or K is the perpendicular bisector between each of these pairs of points. There, said it better that way. Now, if you'd like, maybe you could put in some tick marks on one of them, because we know what's happening here is that T and T prime, when I get to this line K, the line of reflection, this is the perpendicular distance from T to the line of reflection is the same as the line of the reflection to T prime. And that's true in each case because, of course, these are the tick marks for a perpendicular bisector. Since these are your notes, please put that in. Put that in, and I'll come around and check because I want to know that you really understand this. It's important stuff. Okay, now this was an easy one because all we did was verify. I gave you the image or the pre-image and the image. Now, let's see if we can make sense of doing it all by ourselves. Slightly different. Ready? Okay. Next page. Okay. I've got a line over here, a line L, and a point P not on L. And I want to Well, I'm going to break this down into 2 steps. 2 steps. First step is that we are going to construct. It's kind of a big step. We're going to recite a full construction. We're going to construct a line perpendicular to P, or to L, passing through P. That's the right way to say it. So we're going to take our compass, our needle on P, and I'm going to swing a random arc. Yes, this is a random arc. You're going to need a little bit of judgment there. Not too big, not too small. It's going to be just right, because that is going to generate for me 2 points of intersection. I've got an intersection here. I've got an intersection here. And I'm going to put my compass on one of those intersections, and I'm going to swing it through the other. And this is going to look really familiar to you. Now, when we do this, you're going to say, wait a minute, when I do that, imagine if we did the perpendicular bisector construction from these 2 points, because that is in fact what we're doing. The construction for a line perpendicular to a line and a point not on the line, well, is the perpendicular bisector construction once you define 2 points. So I'm going to write down, I'm going to construct a line perpendicular to L passing through P. Whoops. Looks like that. Now we're going to flip our compass over. And I'm going to construct it this way. Swing it that way. And I want to see your full compass swings. I'm leaving you room on the paper. If you get close to going off the page, that's okay. You can just you can just leave it as an arc. But you can fit most of those swings there. Now the 2 orange circles, or arcs in this case, they represent the perpendicular bisector construction. Right? So all you've got to do is line up your Sammy straight edge with these 2 points, or in fact, it should line up with P as well. Those are all collinear. And that's going to give me a line that is perpendicular. And I can even mark that. I'm going to mark a perpendicular right there. Now, remember what our objective is. We're trying to construct the image of P reflected across line L. So we're going to pull out our compass one more time. So our second part is we're going to transfer the distance from P, well, the distance P to L, we're going to transfer it on the other side, the opposite side of L, so over here. And that sounds like a job for another circle. I'm going to put the needle on my intersection. I'm going to gap it to P and give it a swing. Now again, whether you did this with an arc or a complete circle, the result is the same. I've got a point here, over here, that is on the opposite side. And, oh, do I have it over there? I should have put that point there. Dang it. Well, let's cheat and have the computer do it. Check it out. Transformers, reflect. And that will come up P prime. So that is the construction of a point. According to the McGraw Hill folks. Now, and I know half of you have already noticed, yeah, we used 4 compass swings, 4. And we really only need 3. But by using 4, we can show and establish the connection between the perpendicular bisector construction and the construction of a reflected point. So that's the reason we did it this way. We're going to make a quadrilateral next, and we're going to cut down the steps just to cut down the swings, because we've got 4 points to reflect. And at 4 swings each, that's 16. That's a lot. But if we can cut it down to 3, that's going to make it doable. And I want to see greatness on your papers. So we're going to go to this one. Interesting. Very interesting. So we're going to take HJKL and we're going to reflect it across line J. All right. Now, I'm not going to do the whole, I'll show you what we're going to do. We're going to demonstrate a 3-swing construction. And you probably have figured that out. We start out the same. And again, it's a random swing. I'm trying to reflect K. I picked a random arc or a random gap because what I need to do is generate 2 points that are equidistant from K because they're each the radius. Okay. K to T, K to S, same radius of that purple circle. So I've got 2 points. Now, in our previous construction, we said, okay, we're gonna make the perpendicular bisector of ST. That's what we did just a few minutes ago. But now we say, wait a minute, let's take a shortcut. We're just going to gap it this way. We're going to gap it from S to K. Now, when you're doing this, please don't label these points down here. I'm doing that just for the purpose of instruction. You'll go mad if you do that. There's too many. There's too many of them. So let's give this guy a swing. Now again, we're transferring a distance here. This is a different gap. Some of you, it might be by coincidence that this gap also goes through T, but that would be a coincidence, not a normal or an every time conclusive occurrence. Then I'm going to flip it the other way around. I'm going to gap from T to K. Again, not to S, I'm going to K this time. And I'm going to animate like that. Or I'm going to give it a swing. Beauteous. And certainly what you have noticed at this point is that we have an intersection on this side and we have an intersection on this side. Guaranteed to be the image. So that's how with 3 compass swings I can reflect a point across a line. And in this example, what you're going to do, you're going to reflect, 3 more points, and you're going to generate the image of the entire figure. So let's clean this up a little bit. Be aware that this diagram I gave is a little different because H here is on the opposite side. So H is going to reflect over here. Wow, that's going to look really interesting. So I'm just going to show you. Maybe I'll just show you the with little arcs. That's what your compass swings could look like for H. So H prime is clearly going to be over there. Okay. And I'll give you a preview of what you can expect. I'll walk around the room. I want to see that you're doing it right. But your image is going to end up there. Okay? And I want you to visualize what's happening is you are reflecting. It's a reflection like that. So perhaps you're going to use perhaps you'll use different colors or do it faint, but I do want to see all 12 of your compass swings. Whew, that's going to be a tough one, but I know you can do it. All right, I guess that's it, and get this done, and I'll be collecting it and walking around the room to see how you're doing. So everyone, let's call it a day, and I'll say thank you for watching 90 Notes.